You'll find that solving quadratic equations by factoring or completing the square isn't always possible. The quadratic formula is the most powerful technique. This method can be used to solve any equation of the form ax squared plus bx plus c equals 0. When you have a quadratic equation in this form, the two solutions are given by x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. And this formula may look complicated, but it's important to memorize it because these quadratic equations occur all throughout mathematics and you want to be able to solve them. Say we have x minus 2 times x plus 1 equals 0. The two solutions to this are x equals 2 and x equals negative 1. If I FOIL this, I have x squared minus x minus 2 equals 0. Let me plug this into the quadratic formula to see what I get. A is 1, B is negative 1, C is negative 2. I plug these into negative b plus or minus the square root of b squared minus 4ac divided by 2a. And that's 1 plus or minus the square root of 9 over 2. One plus 3 divided by 2 is 4 over 2, which is 2. 1 minus 3 divided by 2 is negative 2 over 2, which is negative 1. And the quadratic formula gives us the same result as factoring. Here's another one. 2x squared minus 4x equals negative 10. The first thing we need to do is add 10 to both sides because the quadratic equation we need is ax squared plus bx plus c equals 0. We need the right side of the equation to be 0. We have 2x squared minus 4x plus 10 equals 0. A equals 2, B equals negative 4, C equals 10. Plug these into the formula. Right, because 16 minus 80 is negative 64, and the square root of negative 64 is 8i. Both terms in the numerator are divisible by 4, and we get 1 plus or minus 2i. And we can't get approximate solutions for imaginary numbers. In the previous case, the solutions were imaginary. Whether the solutions are real or imaginary depends on the discriminant, which is b squared minus 4ac. This is what's underneath the square root sign. If this is negative, you will have two imaginary solutions. If it's positive, you'll be taking the square root of a positive number, and that gives you two real solutions. When it's 0, your solution will be negative b divided by 2a, and that means one real solution. The graph of a quadratic equation is always a parabola. It's always shaped like this. If you look at these graphs here, you can tell the sign of the discriminant by how often it crosses the x-axis. We're graphing the function y equals ax squared plus bx plus c. When y equals 0, that corresponds to the solutions of the quadratic equation. For a, y equals 0 when x equals 2. That's the only time it happens, so that must mean ax squared plus bx plus c equals 0 only when x equals 2. That's one solution. The discriminant must be 0. B. Again, this graph only hits the x-axis at one point. Y equals 0 only when x equals negative 1. That means one solution. The discriminant is 0. For C, ax squared plus bx plus c equals 0 when x equals negative 2 and when x equals 2. Those are two real solutions. The discriminant must be positive. Graph D does not cross the x-axis at all. There are no real numbers that provide a solution to ax squared plus bx plus c equals 0. It must be that the solutions are imaginary numbers. The discriminant is negative for this one.